Hello students, welcome to Saurav Sir's classes. For any doubts or queries in the upcoming video, please WhatsApp us at +91 9836 793076 or email us at sauravsirclasses@gmail.com. You can also visit our website for more information www.sauravsirclasses.com. Today we are solving IIT JAM Statistics 2017 question paper, and the problem that we are going to do now says for C belongs to R, the sequence UN is defined by UN equal to 1 by C plus N, 1 plus C by N to the power N square whole divided by 3 minus 1 by N to the power N. So all this is for a fixed real number C. Then the values of 6 for which the series sum over UN converges are the following. So now what is UN to the power 1 by N, 1 plus C by N to the power 3 minus 1 by N. Let M equal to N by C. Therefore, UN to the power 1 by N is equal to 1 plus 1 by M. You have an N here. So, this is C times M by 3 minus 1 by MC. So by root test, limit as n goes to infinity UN to the power 1 by N has to be less than 1. So what is the limit of this? 1 plus 1 by M to the power M goes to E if M goes to infinity, and M goes to infinity if N goes to infinity and C is positive. Therefore, UN to the power 1 by N, we will assume that C is non-zero, so this term goes to 0 as M goes to infinity, and hence UN to the power 1 by N goes to E to the C by 3, which has to be less than 1. Therefore, E to the power C has to be less than 3, or C has to be less than log 3. If C is less than log 3, then the sequence converges. The series converges by root test. So, B, C less than log E3 is the correct answer. Now let us move on to the next problem. The next problem says, if for a suitable alpha greater than 0, limit x goes to 0, 1 by e to the 2x minus 1 by alpha x exists and it is equal to L, where mod L is less than infinity, then what are the values of alpha and L? Now limit x goes to 0, 1 by e to the power 2x minus 1 minus 1 by alpha x is equal to limit as x goes to 0, 1 by alpha x by e to the power 2x minus 1 minus 1. Now since we have a 1 here, we can ignore this and try to find out limit x goes to 0, 1 by alpha, I beg your pardon, alpha x by e to the power 2x minus 1. Now since as x goes to 0, e to the power 2x goes to 1, the numerator goes to 0 and the denominator also goes to 0, we can apply L'Hospital's rule to get alpha by 2 e to the power 2x by L'Hospital or L'Hopital's rule, which gives us, as x goes to 0, alpha by 2. Therefore L is equal to alpha by 2 minus 1 times limit x goes to 0, 1 by alpha x. Now since x goes to 0, 1 by alpha x goes to plus infinity, if L is, since mod L is less than infinity, L is finite, alpha by 2 minus 1 has to be equal to 0, which implies alpha equal to 2. If alpha by 2 minus 1 is any other constant or infinity, then this entire limit L cannot be finite. So from here we get that alpha is equal to 2. Now limit x goes to 0, 1 by e to the power 2x minus 1 minus 1 by 2x equal to limit x goes to 0, 2x minus e to the power 2x plus 1 by 2x into e to the power 2x minus 1. Now once again by L'Hopital's rule, since once again we have a non-determinate 0 by 0 form, as numerator goes to 0 and denominator goes to 0, we can just differentiate to get limit x goes to 0, 2 minus 2 e to the power 2x by 4x plus 2 e to the power 2x minus 2. This is by differentiating e to the power 2x minus 1 first, which gives us 2 e to the power 2x, and multiplied by 2x, it's just 4x e to the power 2x. And next up we have to just multiply 2 to e to the power 2x, which gives us another 2 e to the power 2x, and we have minus 2. If we look at this closely, the numerator as x goes to 0 goes to 0 because e to the power 2x goes to 1. The denominator goes to 2 into 1 minus 2, which is also 0. So once again we have a non-determinate form and we can apply L'Hospital's rule. So next up it gives us minus 4 e to the power 2x and 4 e to the power 2x plus 4x plus 2, 2 e to the power 2x, 4 e to the power 2x after we fix e to the power 2x and the other term 4x plus 2 times 2 e to the power 2x when we fix 4x plus 2 and differentiate e to the power 2x. So as x goes to 0, we can see the numerator minus 4 e to the power 2x goes to minus 4 and the denominator goes to 4 plus twice into e to the power 2x, which goes to 1, which is equal to minus 4 by, so this is actually 2 because we get a 2 from here and another 2 from here. So this is minus 4 by 8 or minus half. Therefore, B alpha equal to 2, L equal to minus half is the correct answer. Let us move on to the next problem, which says let P equal to integral of 0 to 1 dx by root over 8 minus x square minus x cube. You are given some statements, some bounds for P basically, which we have to check. Now, between 0 and 1, minus x cube is less than 0. Therefore, 8 minus x square minus x cube is less than 8 minus x square, which implies 1 by root over 8 minus x square minus x cube is greater than 1 by root over 8 minus x square. And so if we integrate this function from 0 to 1, we have 1 by root over 8 minus x square, which is equal to integral of 0 to 1 by 2 root 2 whole square minus x square root, which is equal to sine inverse 1 by 2 root 2. Now similarly, x square is greater than x cube between 0 and 1. So minus x cube is greater than minus x square, which implies 8 minus x square minus x cube is greater than 8 minus 2x square, which implies 1 by root over 8 minus x square minus x cube is less than 1 by root over 8 minus 2x square. So the integral of this over 0 to 1 will also be less than the integral of 0 to 1 this, which is equal to integral of 0 to 1 root 2 coming out root over 4 minus x square, which is equal to 1 by root 2 sine inverse half. We are using the formula integral of 0 to 1 by a square 1 by root over a square minus x square is equal to sine inverse 1 by a. So by using this formula, we come to the conclusion that P is less than 1 by root 2 sine inverse half and greater than sine inverse 1 by 2 root 2. So from the options we see that A is the correct answer. Thank you.